Hi everyone. This video is the first video of the year for Algebra 2. We're starting off a little bit differently. And for those of you that haven't followed along with the videos before, basically this is the presentation that I'm going to do in class, that I'm going to do it on the video for you in case you missed it or in case you need to go back and revisit any of the content to review at any point. So we're starting off this year talking about sets and relations, and I'm hoping that what this does is it grounds some of the foundational algebra concepts and some of the vocabulary before we get into the other content. Now, normally I have a little tablet that I can write with. You guys can't see my hands. I'm waving my hands around to write neatly, and I don't have that. Like the pen is missing, and my other tablet is at my house. So, and I'm recording this from school. So the writing might be a little bit messy. I apologize in advance. All right, let's get going. So we're going to start off with what is a set? And you might think of things that you have a set of at home. Maybe you collect something, or you could think of a set of baseball cards or a set of coins, or I don't know, a set of dishes. Essentially, a set is any collection of things. Now, things is not a great math vocabulary word there, but it is broad. Now, in math, we're usually talking about sets of numbers. Okay, I'm writing on the touch screen here. So sets of numbers, it could be shapes, etc. Usually, but not always. Typically in an algebra class, though, we are going to be talking about sets of numbers or collections of numbers. Now, the symbol for sets are these squiggly brackets. Now, I'm not great at making them, but I think you know what they look like, and we're going to see the printed version on the next slide. You do need to try to make your set symbols the squiggly brackets. Okay, I know that some people are not confident making them. You can see how stellar mine are. But what you can't do is say, oh, I'm just going to use parentheses or I'm going to use brackets. Okay, those are not the right symbol to use. They do need to be the little squiggly brackets. Okay, now the items in a set, there are two words that we typically use for the items in a set, and those are the members of the set, okay, or the elements. And I would say those words are used interchangeably. I think I typically say elements in the set, and that's just what I typically do, but both of those words are used. Now, there are operations that we can perform on sets. So you got a set of one things and a set of another things, and we can operate on them. And I'm going to introduce two symbols down here at the bottom. One of them looks like that. It looks like a U, and the other one looks like an upside down U. Okay, now those are not the only operations that we can perform. Okay, there's others. We can take the complement, and there's other things we can do with sets, like find subsets, and there's symbols for all of that. We're going to keep this really minimal. This is our introduction to sets. So that first one is union. And the symbol for union looks like that. Okay, it looks kind of like a capital U. You might make a capital U like that, where it's got a little tab or tag on the end. The union symbol does not, but it does look like a U. So that's kind of how I remember it. If I turn on my little pointer. Okay, here's the capital U in union. Here's the symbol for union. There you go. Okay, so union. Now, the definition of union is this. The definition is essentially the joining of two sets. So if you think of marriage, okay, and we say the union between two people, and it might be the union between two families, okay, maybe not, but a happy world. Okay, it's the union of two families, and so we have one party and their family and the other party and their family, and we're unioning them together, and now we have one big family. Now, one thing about that, do not include any element more than once. So I don't know, this could get really weird with the family analogy, like a marriage analogy, but if somebody is married on one family and they're married to like a sibling on the other family, like it's the same person, but maybe they're a member of both families, and when you join the families together, that person doesn't get duplicated. Okay, it's one person, and just because it's somebody's brother-in-law and someone else's brother, like, okay, but they don't get duplicated. So here's an example of a union problem. So we have here the set of 1, 2, 3, and we're going to union that with the set 2, 4, 6. And so we're going to join the two sets together. And so I open up my sets and I do 1, 2, 3. Now that's my first set. Now when I come over to the other set, there's a 2 over here, but we already have a 2 in that set. So we're not going to write that again. So no 2 again. So we're going to write the 4 and the 6. And that set there is the union. What I usually recommend doing is list everything in the first set first, because you know that's going to be in there, and then go through the second set and just pull the stuff that's not duplicated. Okay, so you just kind of jump over the stuff that is duplicated. The order that you write stuff in your set notation actually doesn't matter. Okay, so if you were to do this problem on your own and you did it like this, you did 2, 3, 6, 4, 1. All right, that would also be correct. So in a set, the order doesn't matter. Think of your math class, okay, and you are a set of students. It doesn't matter what order your name is on my attendance sheet. So I got my attendance sheets here. Okay, you can see them. It's an attendance sheet. You could scramble up the order on the attendance sheet and it would not affect who was in the class. And that's really what a set is. So the order does not matter. Do we usually put them in a certain order? Yeah, we usually do them from least to greatest. That's for our sanity. So it's for the sanity of your teacher, which you should have a vested interest in preserving. But yeah, so you do want to maybe put them in order, but it's not wrong if you don't, okay? And anybody that marks it wrong is not marking correctly. I had a teacher aide when I was in grad school. I taught a class and I had an undergraduate aide who would help grading the homework. And my aide, we were doing sets, and she marked all them wrong if they didn't match what was in the answer key, marked them wrong, and I had to go and regrade all of her work, so that was fun. All right, next one is intersection, and the symbol for intersection is this. It's like an upside down union symbol. Now, I only remember one of the symbols. I remember U is for union and intersection is the other one. There's only 2 of these symbols. So U, union, the other one is intersection. The intersection is kind of what it sounds like. It is the overlap between 2 sets. So it's where they intersect. If you picture like an intersection of roads, okay? So there's my intersection on the road. And here is one street right there that I just did in green. And here's the other street. The intersection is where you have both of the streets. That is like the intersection. It is the overlap between them. So the intersection between 2 sets is the overlap between the set. So here's the example. These are the same sets we had on the previous slide. So the intersection would be the set of, okay? And then you kind of go through one at a time. So 1 is 1 in the overlap? No. 2 is an overlapping number. So 2 is in the intersection. And then you would check the 3. Nope, the 3 is not in the overlap. Now there's no reason to check the other ones because you already worked your way through one set. So the intersection between those sets is a 2. Now you might also see this done in what's called a Venn diagram. So you might see something that looks like this, and you've got the 1 and the 3 and the 2 and the 4 and the 6 like that. And the Venn diagram shows you that overlap. So you've got the 1 and the 3, they are only in the first set. You've got the 4 and the 6 that are only in the second set, but the 2 needs to go where they overlap so that the 2 is technically in both of the circles, so that you can see like and it's called the intersection. So now you can see it, like makes it more visual. All right, so that's intersection. So we got union and we've got intersection. Those are our 2 main operations. Now, what if there's nothing in a set? So what if you've got some kind of set and there's nothing in it? Well, this is called the empty set. Okay, so that's the empty set. And there are two symbols that we have for the empty set. One of them is literally the set symbols with nothing between them. Okay, that's one of the things. The other one that you might see is like a circle with a line through it, like that. So that can also mean the empty set. So both of those would be like sets with nothing in them. So you might be wondering, well, what are some examples of empty sets? Well, I did this with intersections a couple times. So if you have the set 1, 2, 3, 4, and you're intersecting that with the set 5, 6, 7, 8, there's nothing in the overlap. There's nothing in common with both of the sets. And so if we try to Venn diagram that and we have like the overlap, we'd have 1, 2, 3, 4. Okay, we want to make sure they're not in the second circle. And 5, 6, 7, 8 is over there. And the set that we're looking for there is the intersection, which is this piece right here. And you can see that is empty. There's nothing in that set. A second example would be the even numbers intersected with the odd numbers. And that's an interesting example because those are both infinitely big sets. There's an infinite number of even numbers, an infinite number of odd numbers, but they don't have anything in common. So infinitely big, nothing in common. And the last one, just so you don't think it's always an intersection, a third example could be months ending with the letter B. Of course, that's in English. So if we go to another language, maybe something would end in a B, but in English, nothing ends in the letter B. So that set of months ending with the letter B is an empty set. Now, there is a ton more that we could do with sets. So if you kind of like this, I am going to let you know there are several more set operations. You can talk about things like the universal set and the complement of the set. You can find subsets. You can find the number of elements in a set. There's a lot of neat things you can do, and a lot of neat things you can do with Venn diagrams. One of my favorites is with blood type. So there's like 3 different things that your blood type can be. You can have like A, B, and then like a RH factor. So you can have like all these regions of overlap. So you could be like A positive or B negative or AB positive, like, and so forth. So neat stuff that you can do. If algebra is not super your jam, you can take a college class where you do a ton of stuff with sets. This is not that class though. So we could cover an entire unit on what's called set theory, but we're going to focus on what's relevant to algebra. That should be algebra 2, not algebra 1. Can't explain why I wrote that, but I'm not going back and changing it now. Here, I'll change it like this. Well, I'm just going to do this. 2. There we go. Algebra 2. Or, I mean, you could do this in algebra 1. I've taught this in algebra 1. Okay, so what we're going to do is we're going to look at the relationships that can exist between sets. Okay, so you have one set here and you have another set here. How are the two sets related? So this leads us to the second concept of relations. So now that we've covered sets, okay, and we've got the union and the intersection of sets, we're going to talk about the relationship between sets. So a relation is essentially a mapping of one set onto another set. So you start at one set, you kind of have a starting point, and then every element in that set kind of goes over and maps onto an element in the second set. And it probably doesn't mean a whole lot to you right now. We call the first set X and the second set Y. And now you're thinking, all right, now I'm feeling a little bit more like algebra. Okay, first set X, second set Y. And so we're going to look at an example. Okay, so I've got the set X and the set Y. And the set X is 1, 2, 3. And the set Y is 4, 5, 6. So here's what we mean when we say a mapping. We could say that the 1 maps to the 5. Okay, and what we do is we draw like this arrow mapping the 1 over to the 5. So like you just kind of map it that way. We could say the 2 maps to the 4. and we draw like an arrow. And we could say the 3 maps over there to the 6. Okay, now the one I do in class, I don't know how I'm going to map it. Okay, I just made that up. And that's a mapping. So you take your X's and you map over to your Y's. Now, why we call them X and Y is going to allow us to express that mapping as a set of ordered pairs. If you remember, these are ordered pairs. So in these, like the order does matter. If like it's a set, the order does not matter. These, it does. And what we do is we take the element in the first set, X, and we show, hey, this is what it maps to over here in the Y. So for the first one, we had X was equal to 1. And you just kind of follow the mapping. So this is the red arrow. Follow the mapping, and the 1 maps to a 5. And so we've got the ordered pair 1, 5. The 2, and we go like trace the 2, 2 is mapping to the 4, and my 3 is mapping to the 6. Okay, and so you can express that as this set of ordered pairs. Now, as soon as we do that, now that we have a set of ordered pairs, now we can open up the idea of graphing them. What happens if I graph this particular relation? Now, this particular relation, I don't think is going to look like anything, but it could. And so this is why I wanted to start this, where when you're thinking about the graph, you're actually thinking about a mapping. And we're going to take a couple class periods to explore this. Usually there is a pattern in the mapping. Okay, I am down here like on the slide. So usually there's a pattern. If there's no pattern, there's no relationship at all between the first set and how it maps over to the second set, we can't do a whole lot with it. If you're watching this the year I'm recording it, we've spent the last 2 class periods like looking at patterns in like shapes and patterns on the number grid and stuff. If there's no pattern, we're kind of helpless. Now, sometimes there is no pattern, and that's the thing that we need to know. But usually in math class, there is a particular pattern for how you map from one set onto the other, and there's certain features in what that might look like that we're interested in. Okay, so this is the practice set, and generally what I'll do is we're going to do a lesson, and then there will be a bank of problems to practice on. We might start the practice set in class and you finish it for homework. You might finish it in class. You might not. It might be like you don't even get to start it in class. It depends on the lesson and how long it takes. This one is not a super, super long lesson. So what you can do if you're doing this from home is pause the video, work out the numbers on that practice set, and then come to next class with the homework already done. And now you've got the lesson and you got the homework. And even though you had a dentist appointment, you're still good. You haven't missed any math class, so you're not going to fall behind. If you have questions, you know how to reach me. We've gone over that in class. Email, and at least at like the moment, I have no idea how long I'm going to use this video, on Teams will also work to contact me, and I'll see you next class.